Okay, good morning. So let us start the lesson. I will not teach that much, but I will give you a little bit of time to practice yourself. But there are some points that I want to mention. Let us start today's lesson by just one question. So do you remember we talked about if I have a line segment here, so and then let me call them A and B, and then I trisect my line segment into 3 equal pieces actually. So let me call this one P and let me call this one Q. Yes? So this line segment is equal to this line segment. The length of this is supposed to be equal to this and equal to this. You can assume that. Can you convince me what is the relation between XA plus XB and XP plus XQ without doing any calculations? Yes? So I have the coordinate system, I have a line segment in it, call it AB, I trisect it into 3 equal pieces, and then I call one of them P, the other one Q, and I add the x coordinate of this one to the x coordinate of this one. I do the same thing for P and Q. Do you think that there is a relation between this number at the end and this number? Yes?
Are they equal?
Why?
That was intuitive, I don't know.
Yes, intuitive is good, but you need to have a solid argument for that. Yes, you are right. XA plus XB is always equal to XP plus XQ. Yes, but why? Regardless of the length of the line segment, the orientation of the line segment.
Or x of plus x.
Of course, one way to do that, do you remember, we know what is XP and what is XQ. We calculated last time. And then you can use those formulas, add them, and see that this is indeed the case, that it becomes XP plus XQ. So, do you remember, if you have the results from the previous lesson, do you remember what was XP? We calculated XP. It was 2 times, if you look at your notes, 2 times XA plus XB divided by 3, yes? And then of course, we didn't calculate this, but we told that, okay, you can calculate it in a similar way, and the calculation was a little bit lengthy, if you remember. So that was XA plus 2XB divided by 3. But it comes after a long calculation, yes? And then if I ask you what is XP plus XQ, you can immediately use that, yes? XP plus XQ is equal to this one plus that one. So it becomes 2XA plus XB over 3, and then plus XA plus 2XB over 3. But adding these 2 fractions are easy because they have the same denominator. This becomes 3, and then I start adding the numerators, yes? 2XA, another XA here, it becomes 3XA plus XB is here, 2XB is here, so it becomes 3XB. And now what can I do? I can write it as 3 times XA plus XB. Yes, because if I multiply 3 inside, it becomes exactly that expression. And then you see that these 3 and that 3 are cancelled. I get XA plus XB. Of course, if you write this, that is totally right, but assume that you didn't know these formulas. We did a long calculation to get them, and then we can, of course, prove that this is the case. But even without calculation, it should be clear for you that these 2 numbers should be the same. Why is that? Yes?
Well, this is just an idea, I guess, but if, okay, let's say that A is 0, x
Mhm.
right now, and then we know that like the 3 points in that case, xp is a third of b, and xq is 2/3 of b. So
Yes, you are somehow right. But you need a theorem, we haven't studied that yet. But there is a very simple argument behind that. Yes, let me ask you something. If I ask you where the midpoint of AB is and where the midpoint of PQ is,
It's the same.
they are the same. So it was very trivial, but you didn't guess that, yes? Even though it is in front of your eyes. So if I ask you, where is the midpoint of AB, do you agree that the midpoint of AB and the midpoint of PQ are the same points? Yeah, so that's it. So now if I ask you, let us call that midpoint M. What is XM? It is XA plus XB divided by 2 on the one hand, because it is in the middle of A and B. And then, on the other hand, because the same point M is also in the middle of PQ, XM on the other hand is XP plus XQ divided by 2. Agree? So this means that these and that should be the same, because both of them are the same number. And if this number is equal to this number, I can cancel these two, and then these two are the same. So this is the simpler way to understand that. So I want you to broaden your point of view to see these things, okay? Every one of you, after saying that, where are they, you will realize that they are the same points, yes? The midpoint of PQ and the midpoint of AB. But if M is the midpoint, the XM is XA plus XB divided by 2, because M is the midpoint of AB. On the other hand, M is the midpoint of PQ, so it should be also the case. So then it means that XA plus XB divided by 2 should be equal to XP plus XQ divided by 2. Then it means that XA plus XB is equal to XP plus XQ. In this method, if you ask me, do I know XP and XQ, I would say no, I don't know XP and XQ. But I know that whatever they are, these should hold. But here, if you tell me, do I know XP and XQ, I would say yes. So there are two methods, but of course this is much lengthier than the other one. And the same hold. If I ask you what is the relation between the y coordinates, what do you say? They are also the same numbers, yes? Because instead of writing these relations for the x coordinates, I can write these relations for the y coordinates and I get the same result. Yes? Is that clear? Okay, another question for today. So, do you know a parallelogram, yes? A parallelogram is a quadrilateral. Quadrilateral means a shape with 4 sides, yes? So, parallelogram is a quadrilateral with 4 sides, such that opposite sides are parallel. So this one, for example, is parallel to this one, and this one is parallel to this one. If you have such a quadrilateral, it is called a parallelogram. Of course, there are properties of these we will study, but probably you know, at least intuitively, that the length of this side and the length of that side are the same, and the length of this and that are also the same. And then we have some more properties. So the diagonals, if I draw the diagonals here, for example, let me call them A, B, C, D. By the way, if I say parallelogram A, B, C, D, without showing you the graph, the picture, you need to draw it in this direction yourself. I mean that you start from somewhere, and then either you choose to go clockwise or anti-clockwise. So then, for example, if I choose to go clockwise, then I have to give this the name B, this the name C, this the name D. So it is important when I say parallelogram or rectangle or a square ABCD, always conventionally means A and C are opposite to each other, B and D are opposite to each other if it is not expressed in the problem itself. So you are not allowed to write A, B, C, D. Yes? So remember, when I say ABCD is a quadrilateral, and I do not draw the picture myself, this is by convention. You need to understand that A and C are opposite, B and D are opposite. That's a convention. I want you to remember that. Okay, so if I draw this diagonal, and I draw that diagonal, it is clear in this picture that they are not of the same length, of course. Yes, in general. For a rectangle, yes, they are of the same length, but for a generic parallelogram, they are not of the same length. They intersect at some point. Let me call it point M. So if I say, what is this M with respect to point A and C? Can you say something about the point M, the location of point M regarding the line segment AC? Yes?
It's the midpoint.
It's the midpoint. What about the other diagonal?
It's also the midpoint.
It's also the midpoint. Yes? So it's very interesting. Now I want you to prove this. If I have a parallelogram, then XA plus X of the opposite point to it is always equal to XB plus XB. And the same holds. YA plus YC is YB plus YD. So I want you to tell me why. If I have a parallelogram like this, then it doesn't matter in which orientation you draw it. It doesn't matter what are the lengths of the sides. Whatever it is, the sum of the x's of opposite points are equal. XA plus XC is always equal to XB plus XD. It is regardless of the orientation of this in the plane, and it is regardless of the lengths of each side. And the same is true for the y coordinates. Why is that? Yes, Ali?
Because they have the same midpoint.
Okay, yes, that's correct. But can you elaborate more? Can you just tell me why? Because so you can write XM. What is XM?
XM is XD plus XB divided by 2 and XA plus XC
Divided by 2, because the midpoints are the same. So you see that this way of thinking will actually help you a lot to discover things. So what I can write, XM is XA plus XC divided by 2, because on the one hand, M is the midpoint of AC. On the other hand, the same point M is the midpoint of BD. So it is XB plus XD divided by 2. But this is the same number. XM is calculated using this. XM is also calculated using this. But XM and XM are the same. So it means that XA plus XC divided by 2 should be equal to XB plus XD divided by 2. Yes? And then I cancel this, I get that relation. The same relation holds for the y coordinates. Yes? Okay, so let me give you an example here. So here, remember, I mentioned this parallelogram. I named it parallelogram. But here I write the question a slightly different way. I want you to see how do you answer that. So example, consider the points. So, no, let me write it in this way. Let A 1 and 2, B minus 2 and 4, and C 3 and 1, B 3 vertices of a parallelogram. Determine the coordinates of the fourth vertex. Okay, I want to give you a little bit of time to think about the problem. You see, I haven't mentioned the name of the parallelogram to be ABCD. I have just given you 3 points, and I'm asking you to find the coordinates of the 4th vertex, or the 4th coordinate. I give you a little bit of time to think. Yes?
Is it 6 minus 1?
I don't know. We have to check.
Yes.
But what is your method? If you want to, we can draw a little bit. You don't have to, but let us just do it for the clarity here. So that I have a coordinate system. Yes, I have this coordinate system. And then I have point A. X coordinate is 1, the Y coordinate is 2. So this is my point A. My point B is minus 2 and 4. So it's minus 2 and 4. This is point B. And point C is 3 and 1. Yes? So I don't know. My picture is probably not that very good. But I don't know how you want to have it now.
Well,
it seems that they are on the same line, but they shouldn't. If they are in the same line, of course we're going to study later that they are really not on the same line, but they are very, very close. Okay, so what is your idea how to solve that problem? Let me see if GeoGebra has a better picture. Okay, just tell me your method. It's very bad picture. Yes.
Well, in this case, my method doesn't work.
No, it will work probably. So what is your method?
Well, no, my method was that you said that by convention, A and C are opposites and B and D are opposites. But in this case, that's not the case. Because A and D are opposites.
Yes, because so here, if I give you 3 points, so just let me forget about this picture. Let me give 3 points. Of course, if these 3 points lie on the same line, there is no hope for having a parallelogram. Now, let us assume that I have 3 points like this. And then it means that one line would be here, this line would be here, then the other one would be opposite to this one. So apparently, this D will sit in front of A here in this problem. Yes?
Well, in that case, well, what I did, well, I can do it right now, like B plus C is their opposite.
Yeah, so I mean that what is important is that you need to understand which one are the opposite ones, yes? I was thinking that might be we can solve this problem in 2 different ways. Yes, Haya? Yeah?
I used the formula we made it there.
Yes?
And I put in the coordinates of the other one.
Yes?
And then I got X and Y.
Now the point is that actually what I'm discussing with Oscar, which one you take opposite to which. Because here, if I say parallelogram ABCD, then you are forced to assume, based on this convention, that A and C are opposite, B and D are opposite. But here, apparently, we can test it on GeoGebra if they are really the case. But apparently, this doesn't seem to be right, yes? So I don't know if my picture is very poor here. So might be this angle is very big that I cannot see that. But anyway, it doesn't seem that D and B are opposite, yes? It seems that B and C are opposite, and then A and D has to be opposite, yes? We can test this idea, but let us, I can have a better picture on GeoGebra. That's also good to see. Okay, so now we have GeoGebra, so let me put those numbers, 1 and 2. I hope that this will actually give me exactly the same. So 1 and 2 is here. Is this A? Yes, good. B is minus 2 and 4, minus 2 and 4 here. Yes, and then C is 3 and 1, 3 and 1. Okay, so now we understand that it's the other way around, yes? Do you agree with me? So let me draw these line segments from B to A and from A to C. Yes? It's a very, very narrow parallelogram. So where do you think D should be now according to the picture? Because when I drew it myself, I thought that this is bent in this direction, but this is apparently bent in that direction. Do you see? So this angle, so let me, if you don't see that, let me measure this angle for you. So this angle, this is bigger than 180. I was in my picture. I thought that this is bent in this direction, but this is bent in the other direction. So you see, this angle is less than 180. So it means that point D should be somewhere on the upper side of this BC. Yes.
Shouldn't B be connected to C instead of A? Because as we know, A is opposite of C and B is opposite.
No, that's what I'm saying. B, if I so that's my point. One possibility here, because here I just named the points. I didn't mention the parallelogram. I didn't say this parallelogram has to be A, B, C, D. I just gave you 3 points, and I am asking find the other point in a way that it becomes a parallelogram. Which way of reading, it doesn't matter here. So you see that this angle, so this angle is less than 180. So the parallelogram would be, so I have to draw a line parallel. So if I want to make the parallelogram, let us construct it, by the way, using GeoGebra. So I go to this tool, I will take this parallel line, I will take this point, yes, this point B, and then draw a line parallel to AC. This is this point, this line, and I will take the same thing. I will take this point now, and then this line. It will give me that very, very narrow narrow parallelogram. You see that? Let me zoom in, that you can see a little bit better. Do you see the parallelogram now? Can you read it from the GeoGebra? What is the 4th coordinate?
0,
Yeah,
3.
it seems to be 0 and 3. Yes, because if you want to calculate, you can do that. You can go to GeoGebra, use the intersecting tool, click here and click there, and then you get point D, and you can read it here. The point is 0 and 3. Is that understandable?
Yes.
So according to the calculation, you should get the answer 0 and 3.
Yes.
Is there any other possibility? Can I have A opposite? So here B is opposite to C and D is opposite to A. Can I make B opposite to A and having the parallelogram? No, yes? Because there is only one parallelogram constructed. Is that understandable or not? So that is the only parallelogram that we can construct here. I don't know, is that clear for everyone or no? Yeah. So then, if I want to calculate, I can calculate it. So I have to calculate and put D opposite to A and B opposite to C. Don't get confused. You told me, you might say that, Bobak, you told us that B should be opposite to D, A should be opposite to C. If this is the case, if I read it myself for you, if I read parallelogram A, B, C, D. Yes, Ali, do you have questions?
We got a different answer for this question. I wonder if we draw this point, it does become parallelogram or not.
Yes, we can test that one as well. Might be that that's also true. Yes, let us check that. We don't need that, at least you understand that. Here we are taking B opposite to C, A opposite to D. We will calculate it after we have access to the board. But now let me go here, setting, no, it should be on the edit, yes, select all, and then I clean, if sometimes it doesn't work, I don't know, okay. Now, what are your points? So let me put the points first again. So what are the points in the beginning? A is 1 and 2, yes? A is 1 and 2. And then the point B is -2 and 4. Yes, and the point C is 3 and 1. Okay, so what is your point?
The point B is 6 and -1.
6 and -1. 6 here, -1 here. So might be that also works. Okay, so then which one is supposed to be opposite to which one in your calculation?
A should be opposite of C and B should be
Okay, A should be opposite to C. So it means AB is your line segment, yes?
Yes.
So AB is your line segment. Then which one is your line segment again?
I think it should be BC actually,
BC.
the line segment.
Yes, it seems correct. And then you have this.
Yeah.
and then you have this, yes? Yeah, it seems correct. Yeah, so that calculation, that's also very good. So you see, this. So it means that we really have to consider two cases. Yes, we can have A opposite to C, and B opposite to D. Is that the answer that you get, Oscar?
Well, no, I got both of them because I counted 2 times.
Okay.
Both this and the other.
But I mean that this is the point. In these kind of questions, there is no guarantee which one is opposite to which. So we need to consider two cases, yes, and solve the problem. And that is exactly true. I believe that this is also true, okay? So that is good that we somehow get help. Okay. Actually, the reason that I brought this problem is exactly because of that. I myself got confused because that was very narrow, okay? So that I just gave you this example because I want you to understand the difference between this example and that convention. If I myself name the parallelogram ABCD, it means that I am demanding to consider the case that A and C are opposite, B and D are opposite. This is different from this problem. Here I just named 3 points for you, A, B, and C, and I am asking for the last one to make a parallelogram with these 3. If you read this question, it doesn't necessarily mean that I am using that convention. I just want the 4th point. So you need to consider 2 scenarios. Yes? Okay, so one case is to consider A opposite to C, B opposite to D. If that is the case, then it means that x of A plus x of C should be x of B plus x of D. Yes? And the same thing for Y. This is one scenario, yes? If I consider the unknown vertex to be D. Okay, in that case, what is x of A is 1, what is x of C is 3, what is x of B is -2, what is x of D unknown. And then if you calculate this, x of D becomes 6, as you mentioned. Yes? And then the other one, y of A is 2, y of C is 1, y of B is 4, y of D is unknown. Then you calculate this and you get how much? -1. And then you will tell me that D is 6 and -1. As we checked with GeoGebra, it was one answer, one possible answer. But according to this way of reading, there is no guarantee that A and C are opposite and the other. So I can have A and D opposite, B and C opposite. This can also happen, yes? Okay, then what can I do? XA plus XD is equal to XB plus XC, and YA plus YD equals to YB plus YC. Okay, and what is XA? XA is 1, XD is unknown, XB is -2, XC is 3. And if I calculate this, XD becomes 0. And then what can I do now? YA is 2, YD is unknown, YB is 4, YC is 1. So what we get, YD is how much? Is 3. And then this gives me D of what point is 0 and 3. By the way, now I am thinking, is it any other possibility are there? Yes?
Maybe A like opposite to B.
Let us check that one, by the way. We didn't check that. So this is 2 cases, and both of them we demonstrate using GeoGebra. It was correct. It was working. And that instead, so I have A opposite to C, I have A opposite to D, but can I have A opposite to B? If A is opposite to B, then what will happen? For C, I am forced to make it opposite to D because I have only 4 vertices. So you see, I considered A with C, I considered A with D. The only what is left is consider A with B as well. But let us see if it works or not, okay? Let me do the calculation here. If it's going to work, then what will happen? XA plus XB should be equal to YC plus YD. And then what do I have again? YA plus YB should be YC plus YD. So let me go in this direction. XA is 1. What is XB is minus 2. What is YC? YC is, oh, sorry, all of them are X. Okay, so what is XC? XC is 3. What is XD? We don't know. So if I calculate this XD, it's minus 1, it's minus 4. So XD becomes minus 4. And then for Y's, I have 2 plus Y of B is 4, Y of C is 1, Y of D is unknown. And if I calculate that, Y of D becomes what? 2, 4, 6, and 5. So this means that there are 3 solutions, by the way. We didn't consider that last scenario. I think this also works, yes? Don't you think so? So we are making these 2. So it means that when I read the parallelogram for you here, you have to follow the convention. But I have just mentioned that I have 4 points. Find the last point. I am not forcing you to put the last point opposite to A or B or C. So you need to consider all scenarios. Yes? So that would be also a good idea. I'll double check my calculations here and demonstrate it using GeoGebra once more. Yes? So is the calculations that I have done here is right? I am making A and B opposite to each other, so x of A plus x of B should be x of C plus x of D, but x of A is what? 1, x of B is minus 2, x of C is 3. I calculate this one, it becomes minus 4. And then y of A is 2, y of B is 4, y of C is 1, and y of D is not known, so it becomes 5. So it means that one scenario is to consider minus 4 and 5 for D as well. Yes? But we can also check that. That's good. So remember, minus 4 and 5. Okay? Okay, so if we go to the previous picture, if I can get rid of this, yes, I can delete D. So what was D that I got? So I need to also delete these 2 lines. What was that?
Minus 4 and 5.
Let me check. Minus 4 is here and 5 is actually here. That's very interesting. So minus 4 and 5, I don't know if that is really possible. Minus 4 and 5 here. Which one we take the opposite ones? So we are taking A and D opposite to each other. So what are my sides? My sides are
D, A, B.
what?
D to A.
D to A. No, D to A, yes.
B, C, and then A.
Yes, so let me D to A. Yes? And this to this. And that to this. And this to that. That's also working. So you see that this problem has actually 3 different answers. And if this is given, you have to consider all scenarios. So do you understand what I mean? I intentionally named them A, B, and C, but if you consider that A is opposite to C and B is opposite to D, that's only one case. Unless I myself name it, find D such that A, B, C, D is a parallelogram. In that case, you have to consider one scenario, because that is by convention. But if there are a problem like this, you need to consider all cases. So you see that we actually got 3 possibilities here. And all of them should be the solution for this problem. Okay, good. Okay, now my question here is this. That is let me just write the problem. I haven't studied the problem yet, but I understand what they are saying. This is problem 5103 in the book, or at least something similar to that. I don't know where I put this. Okay. Do you remember I talked about the center of gravity of a triangle? Do you remember where it was?
Intersection points of all the
Medians.
medians.
Yes? So now the point is that I give you the coordinates of the vertices of my triangle, and I ask you to find the coordinates of the center of gravity of the triangle. How we can calculate that? So do you know the question? So here, if you want, I can just draw a coordinate system for you, and then I can just draw a random triangle here, something like this. And then what I am asking you, I give you the coordinates of these 3 points. A with coordinates are given, B with these coordinates are given, C is also given. And now my question is that center of gravity, the standard symbol for it is G. My question is that what are the coordinates of the center of gravity of this triangle? So what does it mean? If you remember a little bit about what I told you about the medians, it means that you need to draw the medians. So I find the midpoint of this line segment, I connect these two. This is one of the medians of this triangle. I will do the same thing for the other side. This will be the third one. This will be the second one. The third one is not needed because I told you that there is a theorem that guarantees that the third one also passes through this, even though it is not trivial. Okay? So if I do the third one precisely, this will exactly pass through this point and bisect this exactly. So this point is the center of gravity. My suggestion is that don't distract yourself with the third one. You want to find the center of gravity, the coordinates of the center of gravity, but you need to know something that if you don't know that, you cannot calculate this, or at least I don't know. We can also see the solution manual. Does the author actually expect you to know that or not? The point is that what I didn't tell you, we can prove it later. We can prove it later. If I have any triangle, yes, and this I have this median ABC, and if I draw this median AM, the center of gravity is actually, so if I draw another median, the point is that the center of gravity, this is always the case, that AG is 2 times larger than GM. This is not trivial. We have to show that. So you see, this is a very interesting property of the center of gravity for any triangle. So if you draw the medians, they intersect at a point. That point is called the center of gravity. And there is a very nice property for this point. The distance from this point to the vertex is 2 times larger than the distance from this point to the midpoint. And it doesn't matter which median you are considering. I can consider this median as well. Again, the same is true. The distance from G to B is 2 times larger than the distance from G to this, let me call it N. So I can write BG is also 2 times GN. And finally, if I draw the third one, let me just draw it like that, and let me call this one CP. Again, the distance from G to the vertex, CG, is 2 times larger than the distance from G to P. Yes? Take this for granted and answer my question, which is the content of that problem. Why this is true, it is not probably mentioned in the book, or I haven't checked this book because I know that in Origo book it is not there. But I will talk about this, why this is true. For the time being, take it for granted and use this information that I provided here for you to calculate the x-coordinate of G and the y-coordinate of G, assuming that these numbers are given numbers. You want to find the formula. And for the people who are just going to do Olympiad problems, I recommend you to memorize both of them. Know this is a very, very important fact in geometry, and know this formula that we are going to get. Or if you are using Anki, flashcard, or whatever, put these formulas there. Okay, I give you a little bit of time because now the problem is not hard if you know this. Yes?
The simplest way after simplifying the entire equation is the answer becomes x of b plus x of c plus x of a divided by 3
Yes.
equal to the x.
Yeah, that's a very nice relation. So if you want to find the center of gravity, somehow you average between the coordinates of the points. So you add the x's and divide by 3, you add the y's and divide by 3, it gives you the coordinate of this center of gravity, which is very nice relation. So you're averaging between those three numbers. But how did you get that answer? Can you just elaborate it for us?
Yes, I started by, firstly I needed to find the midpoint.
Okay, so let me just follow you. Okay, and because the y's and the x's are the same, so let us just do the calculation for x's. You can just repeat the calculation for y's. Okay, so you are saying that, okay, I want to find m. So what are the coordinates of m?
X of b plus x of c divided by 2.
Yes, and then of course y of b plus y of c divided by 2. Let us only care about the x's. Okay, and then?
And then I took that, and since the g point is closer to the midpoint, I did that times 2.
Exactly.
Plus,
so you are using that problem that we already did. Yes? So you are saying that, of course, the third point is missing here, but we don't need it. So assume that the third point is somewhere here. This one and this one and this one are the same. So I have a line segment which is divided into 3 equal pieces, and G is the one which is closer to M. So if I want to write x of G, what do you write? The division is by 3, yes? And then I need to take x of A, but I have to multiply this one by 2. So this becomes 2 times x b plus xc divided by 2. Is that understandable for you? You remember I told you this problem before, AB, and then I told you that here we have P, here we have Q. Yes? Imagine that A is the same A. Instead of Q, I call it G. Instead of B, I call it M. Yes? And do you remember I told you the formula for xg? The formula for xg, the denominator was 3, and then you take xa, and then you multiply this by 2. That was the formula we got. Yes? I'm using this formula for this context here. And that becomes finished because these 2 and that 2 are gone. So you see that xa, xb plus xc divided by 3 is your answer. It's very simple, and now we can go and see the solution manual. It is actually very, very long. Okay? So, of course, you might say that I am using that. Of course, you are right. We are using that knowledge. But assume that we don't have that knowledge. It is not very hard to find it during the problem itself. Okay, so let us calculate this, assuming that you really don't know anything about that. Can you do that one as well? So I mean that, for example, because this is not a theorem in the book, you are not allowed to refer to that. Of course, for my exams, that's no problem, because we have already discussed that. If you know that formula, somehow use it, that's okay. Okay? But in general, you are only allowed to use the information in the text, and this information is not given you in the text, that if you want to find the coordinates of P and G, how to do it. Yes? Okay, now assume that you don't know that. Try to do it from scratch, and then still you will see that is much shorter than using the length. The method that they are using in the solution manual, they are using this fact that the length of AG is 2 times larger than the length of GM. This is not good because if you, of course this is possible, it is done, but if you want to write AG, you need to write that distance formula with the square root on top, and then you have to do a very heavy algebra to be able to get the conclusion. But the algebra here was very, very simple. Okay, so I want you to understand the difference between these. Let me solve you this one in this way as well. Assume that you didn't know this formula. So for some reason you have forgotten this formula in the exam. You don't know about that. how you do it here, for example, you find the third point here, let me call it, I don't know, D, for example. Then what do you say? You see that, you see exactly that xm plus xd, yes, divided by 2 is xg. Do you agree with that? So xm plus xd divided by 2 is xg. Why is that? Because g is in the midpoint of d and m. This is one equation. So assume that you forgot about that formula. And then what you say, you can say that xd is xd is xa plus xg divided by 2. That is also true, yes? So these are true. So now, instead of xd, you can put this here. So it becomes xm plus xa plus xg divided by 2 is equal to xg. But you also know what is xm. xm is xb plus xc divided by 2. And then I multiply everything in this by 2. This 2 and that 2 are cancelled. This becomes 4. So this becomes xb plus xc plus xa plus xg divided by 4 is xg. And still, the calculations are simple and we are done. Because if I multiply it by 4, and then I have 1 xg here, I move it to the other side, it becomes 3, and then I divide by 3. So what you see, I multiply by 4, it becomes xa plus xb plus xc plus xg is equal to 4xg. And then I move xg to the other side, this becomes xa plus xb plus xc. I have 4 of them, 1 of them is subtracted, it becomes 3xg, and then I divide by 3. So you see, in this way, I am using only the midpoint formula, which is given to you in the formula sheet. But of course, if you somehow remember this, the calculations is even simpler. You see, the calculation was simple. But if you have forgotten that formula, or even you didn't know this formula, still you can just use the midpoint formula to find that. Yes, but there is still a big if. The big if is that why this is true in the first place. Why these relations are true, we still don't know. We will discover it later. Any questions? Okay. So I stop this section here, and then from tomorrow I will go back to the first chapter, which is actually again continuation of analytic geometry, because then I want to talk about lines in analytic way. Yes, we talked about points here only, and then we want to talk about lines. Yes, so I think that is also the continuation of analytic geometry. Thank you.